Welcome back to Math 160 Statistics 1. In this mini lesson, we're actually going to be looking at hypothesis testing. So we're going to look at the same data set that I use for constructing a 95% confidence level interval, the lengths of newborn babies to non-smoking mothers. And I'm going to do some hypothesis testing here. So I have a claim, and I wrote that in the Excel spreadsheet. So the claim is that newborn babies born to non-smoking mothers have an average length greater than 57 centimeters. That is my claim. So my null hypothesis is that the mean is equal to 57, and my alternative hypothesis is that the mean is greater than 57, and we're referring to centimeters. So how we would do this in Excel is actually kind of tricky. So let me first introduce a second column here. I want you to think about the fact that we want to use our t distribution, right? Because we actually do not know the population standard deviation, and we essentially want to construct this hypothesis test. So what we're going to do is we're going to create a dummy variable, and I'm just literally going to call it dummy. You can call it anything you want. And I'm just going to input a couple zeros so that we have more than one data point. It's literally tricking Excel into doing what we need it to do. So it's a little strange, but you'll see exactly how this works. So we're going to go back to this data analysis tool. And this time we're going to click on t-test for two samples assuming unequal variances. So we're going to click this. We're assuming unequal variances because, I mean, there are two different data sets and the second set has two zeros in it. So that should make sense. So for our input, our variable 1, that is going to be our lengths of newborn babies. I press enter. For variable 2, we're going to select the dummy cells, and I'm going to press enter. Hypothesized mean difference. So we're looking at 57, right? We're looking at mu is greater than 57. So we know that we have labels in our first column, so I'll select that. And let's say that our alpha in this case is 0.05. Your alpha could really be any variation, right? We've seen 0.01, 0.05, 0.10, 0.005, whatever it is, go ahead and write in your alpha into this spot. We're going to use 0.05 in this case. I'm going to select output range. I still want it to output here in this particular worksheet. So I'm going to go ahead and select just a pretty large region. It doesn't really matter. We go ahead and click enter, and then we'll click on OK. So notice the information that we're provided here. We have the mean, the variance, observations. We have the degrees of freedom, which are 14. Notice we have the t statistic. Now, I want you to consider what we're seeing here. Mu is greater than 57. From our conversations in class, we realized that this is one-tailed. Specifically, it's a right-tailed test, right? Mu is greater than that particular value. So you're looking at the probability, right? Given that this is a one-tailed test. So essentially, we are looking at this p-value. If that seems a little strange to you in the way that it's actually written out, we can expand on this decimal just so you can see exactly how small this is. So essentially what's happening here is that that decimal is going to move 6 places to the left. So it's pretty close to 0, right? Your probability is pretty close to 0. You're then going to compare your p-value with the alpha. So that's something we should note, compare the p-value with alpha. And we learned in class that if the p-value is less than or equal to alpha, then we're going to reject the null hypothesis. That's going to be the decision. If your p-value is greater than alpha, then we are going to fail to reject the null hypothesis. In this case, notice that my p-value is incredibly small. It's like 0.000001, right? Something incredibly small. And we see that alpha is 0.05. That's what we established when we started this. It was the alpha input that we had in that box when we were trying to calculate all of these values. So we see that the p-value is definitely smaller than alpha. So we reject the null hypothesis. Okay, there is sufficient evidence to show that the average newborn length in centimeters to mothers who do not smoke is greater than 57. There's enough evidence to show that. All right, hopefully that helps. Consider the fact that in this case, it was a one-tailed test. So you're looking at your p-value, your probability for one-tailed. If for whatever reason we had mu not equal to 57, meaning it could be smaller, it could be greater than, but it's not equal to, this becomes a two-tailed test. And then we would be looking at that p-value instead. Okay, something to think about. I hope that this was helpful and enjoy the rest of your day.